Hi everyone. So let's go ahead and take a look at section 2 of chapter 23. And this is looking at the upper respiratory tract. So remember in the last section, we looked at how the respiratory system can be divided or broken up into either a functional or a structural organization. The structural organization, I broke it up into the upper respiratory tract and the lower respiratory tract. So this one we're looking at the upper respiratory tract. So we're going to be taking a look at the nose, the nasal cavity, the pharynx, and also the paranasal sinuses as well. So let's start off by looking at the nose and the nasal cavity. Here it is right here. So there's the nose. This is the first and main conducting passageway for inhaled air. We're going to talk about how it's really important to make sure that we breathe in through our nose. We can breathe in through our mouth, but we're going to be missing a key process, something that needs to happen in the nasal cavity. So we'll be looking at that here in a second. Now the book's going to go through all of these structures, all of the different cartilages, but also other little parts that I'm not going to get into. There's even more on the next picture. So if you're interested in the different little parts of the nose, then read all about it in your book. But unfortunately, since this is a massive chapter, we don't have time to go through all of the anatomy. So let's go ahead and take a look here. So we breathe in through our nose, and here's that nasal cavity right here. And let's focus on what these things are. So it shows the nasal cavity. It's kind of pointing to these interesting little structures that we have in the nasal cavity. So let's take a look at them over here. So this is kind of the same picture, but a little bit more on the labeling on this picture, right? So these are going to be something called nasal concha. I say it a little differently. So let me tell you about some of the pronunciations I have. I took mammalian physiology from a man from Trinidad and Tobago, but he grew up and had a British influence. So all of these terms that I kind of learned and embedded in my brain are British English. So I know that, so I've always just called this concha. But I know that, of course, US English, you should say conky. So I've even heard concha as well. So whichever one you want to say is just fine with me. But I digress. So there's the nasal concha, and they're also termed turbinate bones. So this is a really creepy but cool picture right over here. But I didn't put it in there. The book put it in there. But I wanted to focus on it because you can kind of get a better idea of what the shape of the nasal concha is looking at it this way. So if we have that septum, what you're going to have are these kind of bones that are coming off like this. And they are going to, of course, be covered by that pseudostratified ciliated columnar epithelium. And you have it on the other side as well. So it's like if you were looking straight through, if I cut my nose off or cut my face like that and was looking straight like that, you would have it on both sides. That's your concha, conky. And in between, these little spaces in between are the meatuses. And what's great about these is it is going to increase the surface area in that nasal cavity. So whenever the air comes in, whenever you breathe in the air, I know air is not going to come in this way, but you guys get the picture, is whenever you breathe in air, as soon as it hits one of the concha, it is going to swirl. And it hits here and it swirls and it swirls. And what this is good for is it's going to help break up that air and turbinate that air. So that's why these are called turbinate bones. We'll talk about how important it is in a second when we put all of the mucus together with the nasal cavity and the paranasal sinuses and things like that. So these are the turbinate bones that are going to kind of swirl that air, break it apart, and make sure that we condition it appropriately. So that's the beauty right there of the nasal concha. Let's go ahead and move on to some other parts. Let's go ahead and look at the different regions of the nasal cavity here. So it's broken down, as you can see, into 3 different regions, and they are color-coded, which is really nice. So you have this nasal vestibule right here, the greenish color, and this is going to be, of course, as you can see, lined by the skin. You're going to have these little hairs that are going to stick out. Hopefully not sticking out. You might have some sticking out. That's just fine, right? Or you might not have any, so some of them are going to be inside. But really what they're there for is to trap any kind of particles that you are breathing in. Hopefully, you know, it's anything like large bugs or anything like that. Tiny little microscopic things will probably get through and past these little nasal hairs, but that's what you are going to have that pseudostratified ciliated columnar epithelium that's covered in mucus for, is to trap the other things that get past these little hairs. So this is where we are going to first breathe in, is that nasal vestibule. Then we're going to have the olfactory region up here. That's another region, and that's called appropriately so, right? Because that's where the olfactory epithelium is going to be. You can kind of see it with the little cribriform plate, little holes right there. That's where the receptors are going to go through, the axons are going to go through. So when we do breathe in that air where all the particles are going to be, we breathe it in and it goes all the way up and hits those olfactory, the olfactory epithelium up there. And then the biggest portion right here is going to be this respiratory region. And again, pseudostratified ciliated columnar epithelium. You'll hear me say that over and over again. Until, of course, later on when we get away from the anatomy and get a little bit more into physiology. But this is going to be a nice mucosa that's going to have extensive vascular network. So lots of superficial capillaries in here. If you've ever had a nosebleed, then you know what I'm talking about. It's because of the superficial vessels that are going to be found there right underneath the epithelium. But we're going to talk about how important it is here in a second when we talk about this whole conditioning process that's going to occur. And there it just gives the other term for nosebleeds, epistaxis. Can't say that either, apparently so. You also have the nasolacrimal ducts. They don't show it in here, but if I were to go in and draw it on this guy, it would sit right in the corner of his eye. Remember, it's going to kind of go down and connect. So there and drip. I wish I had a different picture. But you should be able to go back to your sensory chapter, one of those nervous system chapters, to take a look. Whenever you cover the eye, it covered that nasolacrimal ducts, and this is where the lacrimal secretions are going to drain from into the nasal cavity. So that's why when you do cry, you feel like you have a runny nose, because a lot of the lacrimal secretions, your tears, are going into your nasal cavity because of that joining right there. So let's talk about this whole importance of the pseudostratified ciliated columnar epithelium, this importance of this vascular network that we are going to have here in the respiratory region. The reason why it's so, and of course the concha as well, and why it's important that we turbinate that air. The reason why it's because we need to condition the air. That's the good thing about the nasal cavity and all of the structures and all of the tissue that's going to be found inside of the nasal cavity, is because it warms it, it filters or cleans it, and it also is going to humidify it or moisten it. So the air is going to be warmed by those blood vessels that I talked about. So the blood vessels are going to sit right underneath. So remember that we have that areolar connective tissue that had the blood vessels underneath. And then, of course, here was that epithelium that we have. I'm going to try and draw the best pseudostratified ciliated columnar epithelium that I can, but it's really hard whenever I don't have a whole lot of time, right? Cilia. So as you can imagine, you have these superficial vessels, and remember that blood is going to be a little bit warmer than normal body temperature. So that warm blood is going to, of course, radiate up here. And anytime the air hits, that air is going to get warmed as well. Remember that we also have that layer of mucus that's sitting on top. So whenever the air is turbinated and swirled and hits that mucus, it is going to, not only are particles going to get trapped inside of the mucus, but it's also going to pick up some of the condensation from the mucus. Remember, we talked about how mucus was a combination of mucin, protein, and water. So that is how it's going to get humidified and moisten, is from that. So that's kind of the great thing about this nasal cavity and this mucosa well, the entire respiratory mucosa right here. Well, that's what I just said, mucosa. Yeah, the entire respiratory mucosa. And the concha as well, helping to swirl that in. So let's go ahead and take a look at these paranasal sinuses. These are going to be spaces in the skull. So you might remember these from 2401. You have four of them. They're going to sit in the frontal bones, the ethmoid bone, the sphenoid bone, and the maxilla as well. So they are going to be named by, of course, the bones that they are going to be found in. These should be kind of air cavities, so spaces in the skull. They are still lined with that pseudostratified ciliary columnar epithelium, and they still produce mucus, but not too much mucus. You'll still have it to where these are going to be filled with space, with air. So that helps kind of lighten the skull a little bit. Another thing that it does is it does help with the whole conditioning process as well, since you still have that, say it with me, pseudostratified ciliated columnar epithelium that's going to line it. It's going to go along with that. The mucus that, look at the ducts. They are going to eventually kind of drain into that nasal cavity. So any mucus that's swept from there is going to go into the pharynx, and it's going to be swallowed, and it hits the stomach, and then there's the hydrochloric acid that's going to be there to help kill off any kind of microbes that we might have caught inside of that mucus there. These are also going to be really good for resonance with your voice. If you've ever had a sinus infection or sinusitis, sinus infection, sinusitis, anything like that, then you can tell how they play a major role in your voice, because you sound a little bit different whenever you're all stopped up, and that's the reason why. Not only, of course, is your nose and nasal cavity stopped up, but these can get stopped up as well. So anytime that you have sinusitis, a sinus infection because of a bacteria or a virus, what happens is that, again, the mucosa is irritated, produces lots and lots of mucus. There goes the space, and the space is filled with mucus. And sometimes it can be to where they are blocked and it can't drain into the nasal cavity. So you just have all of these sinuses that are in there filled with mucus, and that's where you kind of get that pressure headache that comes with sinus infections, which is no fun, right? All right, let's move on to the very last part of our upper respiratory system, or upper respiratory tract, and that is going to be our pharynx. So I introduced these terms earlier earlier in section 1. So let's go ahead and reiterate them. Before I talked about them when we talked about how the epithelium changes, but I hadn't introduced these structures yet. So now we can talk about it and talk about how the epithelium changes as well. So look, you have the nasopharynx. You can see it over here as well. So you can kind of see how it goes from here to here. And then you're going to have that oropharynx, and probably a little bit lower than that. Yeah, it kind of goes in and takes that. And then you are going to have, oh, mine's really off, so sorry. There it is. And then the laryngopharynx. And the laryngopharynx is going to, eventually, it's going to lead to the esophagus. So let's talk about these different parts. So you do have lateral walls composed of skeletal muscle. So we will talk about this again when we get to the digestive system, because we are going to talk about how they help with swallowing. But let's first take a look at this nasopharynx right here and all the little parts that are involved. Look at this pharyngeal tonsil, that adenoid that's going to be found in there, that lymphatic structure we know and love, right? We've talked about that. In children, they're actually enlarged. They're large. I don't want to say enlarged, but they can be in children, very large, to where it causes issues and they have to get taken out. But they are usually larger in children, and then as we get older, they are going to get smaller and smaller, kind of like a thymus. Kind of interesting. So that's what you have here is going to be that pharyngeal tonsil. Look, you are going to have the opening to the eustachian tube, that auditory tube as well. So that's why sometimes if you do get kind of a an upper respiratory infection, it can kind of go in, affect of course, the pharynx, and then travel up and affect that ear as well, because it's going to be continuous. Remember, the epithelium here is a pseudostratified ciliated columnar epithelium. So because it's kind of, look at that, it's continuous with that nasal cavity. When we move down to the oropharynx and the laryngopharynx, it is going to change to that stratified squamous epithelium. And remember why? It's because of the fact that these are going to be subject to anything that you put into your mouth, anything that you ingest. So we need to have that protective layer. We don't have to worry about the whole, the function of the pseudostratified ciliate columnar epithelium. We need to worry about protection more in this area. So we'll talk about how we don't have to worry about that, because usually this this palate is going to elevate and block off the nasal cavity when we eat, but sometimes, you know, it doesn't. It kind of spasms a little bit, and that's when food or water can sometimes go this way. Not food, that would be, well, I mean, you've seen those people, right? Take a spaghetti and go from their mouth and put it through their nose. It's pretty gross. So, but if you can do that, then that's pretty interesting. So, all right, I digress. Let's move on down to that oropharynx. Again, changing to that non-keratinized stratified squamous epithelium. Let's take a look at what we have in here. Do they not have those on here? No, they don't even have the palatine tonsil. I'm going to draw in a palatine tonsil, because that's one structure that's going to be, it does not want me to draw a palatine tonsil. Remember that they are going to be found in here. And you also have the lingual tonsil as well. So those are going to be parts of the oropharynx. I think you can kind of see it there. I think that's a palatine, right? No, I don't think that's it. Anyway, I digress. So just make sure you know that your other tonsils are in the oropharynx. And then here's that laryngopharynx, and that is going to be, there's no tonsils here. It's still stratified squamous epithelium. So we're really just kind of going through the whole airflow process, right? It's coming in through the nose, going to the nasal cavity, getting conditioned in here before it is going to go down the pharynx. And then we're going to talk about how we need it to go this way. So that's the way it's going to go, and that should bring us to the lower respiratory tract. But another thing I want to talk about, how these two, why I was talking about the whole food and the spaghetti thing, is because these two are actually shared with the digestive system. They not only does air pass through them, but so does food and liquids, anything that you ingest. Not so with the nasopharynx. That's what I was trying to go at whenever I was talking about that. You shouldn't have any kind of ingested material go in here. So this is air passage only. These two are air and ingested materials as well. So again, from here we go into, we start into the lower respiratory tract, which is the larynx. So that is where we will pick up in our next section. So until next time.